Nonlinearities, both hard and soft, can be detected in a number of ways. One of them is to provide different inputs which are of the same type but have different amplitudes. Of course, if the system is linear, the output will have the same shape in all cases, and the amplitude of the output will be proportional to the amplitude of the input. If this does not happen, we know that the system is not linear. For instance, in this case that I am drawing, there is no proportionality between the amplitude of the input and the amplitude of the output, and we see that the plant is not linear. Even if there is proportionality in the amplitude of the output, at least in the amplitude of the output in steady state, if the shape of the output is not the same, then there is no linearity again, and we see that we are in the presence of a nonlinearity. Another way of checking the presence of nonlinearities is to see what happens to the output of the system when the input is sinusoidal. Remember that if a plant is linear and stable, then when its input is a sinusoid, its output in steady state will also be a sinusoid with the same frequency of the input sinusoid. For this to be true, however, the system must be linear and stable. We have here represented the outputs of the model of a system when the input is sinusoidal. This model models a system which is a wave energy converter, but the exact nature of the system is irrelevant for the point that I'm trying to make. The point is that the input is sinusoidal and that a long time has passed since the beginning of the simulation. Consequently, we can be sure that the transient regime is gone. Now, what is the output of this model to sinusoidal inputs? Is the output sinusoidal? Clearly no. This shows me immediately that the model used in these simulations is a non-linear model.